Hey guys, so for today I want to talk about this. Now for those of you unfamiliar, this is the Japanese Maglev bullet train, also known as the world's fastest bullet train in existence. Now today I want to just talk about one aspect of how this train is able to go so fast. In fact, 400 kilometers plus per hour, making it the fastest train alive. But how is this possible? Well, in today's experiment, I want to talk about just one aspect that makes this completely possible. So for today's experiment, the materials that we're going to need are pretty simple. Just a base, any sort of plastic base, any sort of stick. The stick doesn't really have anything to do with it. And at least 3 of any of these sort of circular magnets. Make sure that there's a hole in the middle so that the magnets can fit through the stick. So before we begin the experiment, I just want to go over the very basic concept that we're going to be going over today, and that is the concept of magnetic field lines that come with magnets. If we look at the images below, you can see a bunch of different examples of these. So imagine these magnets, obviously there's positive, negative side. Imagine if that each side of them has sort of like a force field. As seen in these pictures, these are known as magnetic field lines. And so if you've ever wondered why positive and negative attract, it's because the magnetic field lines, since they're of opposite polarity, they're able to attract to one another, hence sort of like the picture like this. But what happens when things repel? Since they are the same polarity, the magnetic field lines constantly avoid each other since there's no attraction between them. And this today is going to be the very basic concept that we go over in today's experiment. So to set the experiment, we just kind of get the base, we put our stick through it, and we're going to stick one magnet through it. This is going to be our anchor. So since we have the red side at the bottom and the blue side at the top, we want to make sure that with the second magnet, we put the blue side on top. That way it's having the same polarity. And thus, we can see through this the very concept of the magnetic field lines repelling each other, because no matter how hard I press down on it, the moment I let go, it just repels. So why do we need a third magnet then? Well, in this example, we're gonna have the red top, so we see how it's red. We're also gonna put the red top on the bottom of this third magnet. And you see how there's a constant space in between them. This is similar to how the bullet train works. Imagine that these two are the rails of the train. Imagine this middle is the train. So having the rails on the outer part of the train helps keep the train in line constantly while it's moving at such high velocity. Why does this matter? Another concept that we go over this is the fact that if we look, no matter how far we move this baseline, there's going to be constant repelling due to the electric field lines. So that's one reason how the train is able to go so fast, because it doesn't have to deal with the concept of friction between the track and itself. The train's going to be constantly floating on top of the track, thus neglecting friction, which can, in theory, make the train go a lot faster since there's less forces resisting against it. Hence, since we move this base, imagine that this base itself is the train, or this magnet itself is the train, and these are the tracks. As the train moves through, it's constantly going to be levitating, and it's not going to be levitating enough that the train just leaps into the air, because there's a certain amount of gravity working against the train to push it down, and hence why it's not just levitating forever up. Now that we understand this very basic concept of magnets, we can now go into more complicated things as to exactly how the train's able to do this. So one of the concepts is magnetic flux, which is defined as a measure of the number of magnetic field lines given across an area. So say that magnetic field line is going from here and out, it's going to be the amount of magnetic field. The magnetic flux is going to be the amount of field lines that are actually going across to this area, which would be 0, because these two are repelling each other. So in the case of the train, there's going to be no magnetic flux actually on the train, since these two are not attracted to each other, and these two are also not attracted to each other. Hence, there's no number of magnetic field lines crossing through the train, since they are constantly repelling. So now one question that you may come across is, if we have this example here, and this is what we're basing the train off of, why does the train be able to touch the ground, such as this, wherever it stops? Well, this is where we get into the concept of electromagnetic induction, which is basically the introduction to electromagnetic induction. Now I want to save this for a different experiment, as the first experiment we ran today just wants to go over the basic concept of magnetism. But in essence, the electromagnetism is affected by the number of loops within the coil itself. As electricity runs through it, the more loops, the more it'll affect the current. But the main thing I want you to get out of this is that the current of the electricity that runs through these loops affects the magnetic poles of this. So by changing the direction of the current, we can change the polarity of whatever magnet we're having. Hence why we're able to land. The bullet train if it's represented by this one. If we could change, as we can see here, if we can change the polarity of it, so instead of being blue to blue or positive to positive, we run it through electromagnetic coil, changing the current. See, we can now attract, and thus the train can land, not constantly floating. And that's the basic concept behind the Japanese bullet train. And one of the reasons why it can go so fast is that there's no friction between the tracks like this would be, and the only resistance it mainly has in terms of friction is air resistance, since it's floating up here, thus being able to make it go so fast, or one of the main reasons.